Imagine calculating the trajectory for the first American spaceflight by hand. Your mathematics so trusted that astronauts refuse to fly unless you personally verify the computer's work. What you are about to discover is the story of a mathematical genius whose calculations sent humans to the moon, yet whose contributions were deliberately hidden for decades behind barriers of racism and institutional secrecy. In a segregated basement office at NASA headquarters, a black woman covered sheets of paper with complex equations that would determine whether astronauts lived or died, her brilliance confined to a space the agency didn't want the public to know existed. This is the extraordinary tale of Katherine Johnson, a mathematician whose mind could perform calculations that early computers struggled with, whose work was essential to America's space program, yet whose name was erased from history until she was nearly 100 years old. Born Katherine Coleman on August 26, 1918, in White Sulphur Springs, West Virginia, she demonstrated extraordinary mathematical ability before she could read, counting everything around her and solving complex problems in her head. Greenbrier County, where she grew up, didn't offer public schooling for black children beyond 8th grade, forcing her family to move 120 miles away each school year so Katherine could attend high school. By age 10, she had enrolled in high school, and by 14 she had graduated and entered West Virginia State College, a historically black institution where her exceptional talent caught the attention of mathematics professor William Waldron Schieffelin Claytor. Claytor, one of the first black Americans to earn a doctorate in mathematics, recognized Katherine's genius and created advanced courses specifically for her, including analytic geometry that wasn't part of the standard curriculum, preparing her for a mathematical career. She graduated summa cum laude at age 18 with degrees in mathematics and French, an achievement remarkable for anyone but extraordinary for a black woman in 1937 America. After teaching mathematics at a black public school in Virginia, Katherine was selected in 1939 as one of 3 black students to integrate West Virginia University's graduate programs, a historic moment in the state's desegregation. If these stories of hidden pioneers who changed history from the shadows inspire you, subscribe to Hidden Minds and hit the notification bell to discover more forgotten geniuses whose contributions were deliberately erased. Check the link in the description for historical documents, mathematical analyses, and additional resources about Katherine Johnson and other overlooked figures who shaped the space age. However, after 1 semester, Katherine left graduate school when she became pregnant with her first child, a decision that reflects the impossible choices women, especially black women, faced between family and career. For over a decade, she focused on raising her 3 daughters while teaching mathematics, her extraordinary talents confined to a classroom when they could have been advancing scientific research. In 1952, at a family gathering, a relative mentioned that the National Advisory Committee for Aeronautics, NASA's predecessor, was hiring mathematicians at its Langley Research Center in Virginia. The agency needed human computers, mostly women who performed complex calculations by hand to support aeronautical research, and for the first time was hiring black women for these positions. Katherine applied immediately and in 1953 joined the West Area Computing Section, a segregated unit of black women mathematicians working in cramped conditions separate from their white counterparts. The women of West Computing faced daily humiliations, forced to use separate bathrooms located half a mile away, eat at segregated tables, and see their work attributed to white male engineers who presented their calculations. Despite these obstacles, Katherine's mathematical brilliance was undeniable, and within 2 weeks of joining Langley, she was temporarily assigned to the Flight Research Division to help analyze data from a plane crash. That temporary assignment became permanent when her supervisor realized Katherine's analytical abilities exceeded those of most engineers in the division, though she still faced the barriers of being both black and female in a white male-dominated field. Katherine's specialty became trajectory analysis, calculating the precise paths that aircraft and spacecraft would follow, work requiring an intuitive understanding of orbital mechanics and advanced mathematical techniques. When NASA was established in 1958 and the Space Task Group was formed to put Americans in space, Katherine's expertise made her indispensable despite the agency's reluctance to publicly acknowledge black women in their workforce. She performed the calculations for Alan Shepard's 1961 flight, the first American in space, determining the trajectory that would keep him alive during his 15-minute suborbital journey. Her work was so precise and reliable that astronaut John Glenn, preparing for his 1962 orbital flight aboard Friendship 7, specifically requested that Katherine personally verify the electronic computer's calculations. Glenn reportedly said, "Get the girl to check the numbers," referring to Katherine, trusting her manual calculations more than the new IBM computers that were being introduced to handle the complex orbital mechanics. This moment, dramatized decades later in the film Hidden Figures, represented a profound statement about Katherine's abilities, that the astronaut's life depended on her verification of machine computations. Katherine's calculations for the Mercury missions required her to solve complex differential equations describing orbital paths, work that combined physics, astronomy, and advanced mathematics in ways few people could comprehend. She co-authored research reports with white male engineers, though her contributions were often minimized and her name sometimes omitted from presentations or public discussions of the work. The culture at NASA during the 1950s and 60s was deeply segregated, with black employees facing restrictions on where they could work, eat, and even use restroom facilities. Katherine challenged these restrictions through quiet persistence, attending meetings she wasn't officially invited to, asking questions that forced engineers to acknowledge her expertise, and simply refusing to accept the limitations placed on her participation. Her supervisor, Dorothy Vaughan, who led the West Computing section, had fought similar battles to gain recognition and opportunities for the black women computers under her supervision. Together with Mary Jackson, who struggled to become NASA's first black female engineer, and countless other black women, Katherine was part of a hidden workforce whose contributions were essential but deliberately obscured. Katherine's most celebrated achievement came in 1969 when she calculated the trajectories for the Apollo 11 mission that landed humans on the Moon. Her backup navigation charts and abort procedures gave astronauts Neil Armstrong and Buzz Aldrin confidence that if the primary systems failed, Katherine's calculations would bring them home safely. The precision required was extraordinary, calculating velocities, fuel consumption, gravitational effects, and trajectory corrections across 250,000 miles with tolerances measured in fractions of degrees. Any error in Katherine's mathematics could have meant the astronauts missing the Moon entirely, crashing into its surface, or being unable to return to Earth, making her work literally a matter of life and death. She also worked on the Space Shuttle program, Earth Resources satellite missions, and plans for a mission to Mars, contributing to NASA projects across more than 30 years. Katherine co-authored 26 research reports during her career, groundbreaking work in orbital mechanics and space navigation that advanced humanity's ability to explore beyond Earth. Yet despite these achievements, Katherine remained virtually unknown outside NASA, her contributions hidden behind classification restrictions, institutional racism, and a culture that didn't want to acknowledge black women as scientific pioneers. When NASA published histories of the space program or held public celebrations, the focus remained on white male astronauts and engineers, with the contributions of women and minorities systematically erased. This erasure wasn't accidental but reflected deliberate choices about whose stories deserved to be told, whose faces could represent American scientific achievement during the Cold War. Katherine retired from NASA in 1986 after 33 years of service, returning to a quiet life in Virginia without the recognition her contributions deserved. For decades, she lived in obscurity while history books celebrated the space program without mentioning the black women whose mathematics made it possible. The turning point came in 2010 when Margot Lee Shetterly began researching the story of black women mathematicians at NASA, work that would become the book Hidden Figures. Shetterly's research uncovered the systematically hidden contributions of Katherine Johnson, Dorothy Vaughan, Mary Jackson, and dozens of other black women who had been written out of space program history. The book, published in 2016, became a bestseller and was adapted into an acclaimed film that finally brought Katherine's story to public attention. At age 97, Katherine suddenly found herself celebrated as a national hero, receiving the Presidential Medal of Freedom from Barack Obama in 2015 for contributions the nation had ignored for 50 years. NASA renamed their Independent Verification and Validation Facility the Katherine G. Johnson Independent Verification and Validation Facility in her honor in 2016, a building dedicated to checking spacecraft calculations, fitting tribute to her legacy. Congress awarded her the Congressional Gold Medal in 2019, and her face appeared on postage stamps, her story taught in schools, her name finally recognized as synonymous with mathematical genius. Yet this late recognition couldn't erase the decades of invisibility, the years when her work was attributed to others, the countless moments when racism and sexism denied her the acknowledgement she earned. Katherine's story represents not just individual achievement but systemic injustice, revealing how many brilliant minds have been hidden throughout history because they didn't fit the expected image of a scientist. She worked in an era when black women faced double discrimination, judged inferior both for their race and gender, their intelligence questioned regardless of their demonstrated abilities. The calculations Katherine performed are now done by computers in microseconds, but her pioneering work established the methods and verified the mathematics that made space exploration possible. Her ability to visualize spacecraft trajectories, to understand how objects move in three-dimensional space under gravitational influences, represented a rare combination of analytical skill and spatial intuition. Katherine lived to see her contributions finally acknowledged, passing away on February 24, 2020, at the age of 101, having witnessed humanity's transformation from early spaceflight to international space stations. In her later years, she inspired countless young people, especially girls and minorities, showing them that mathematical brilliance knows no boundaries of race or gender. Her life raises uncomfortable questions about how many other Katherine Johnsons existed throughout history, brilliant minds whose contributions were hidden, whose names we'll never know because documentation was destroyed or never created. How many calculations were performed by unnamed women, How many discoveries were attributed to the men who supervised them? How many potential geniuses never got the education or opportunities that Katherine barely received? The mathematics Katherine performed still underpins space navigation, her trajectory calculations forming the foundation for systems that guide spacecraft to distant planets and asteroids. Every successful space mission, from satellite launches to Mars rovers, builds upon the mathematical frameworks that Katherine and her colleagues established in those early years of space exploration. Her story reminds us that history as written often reflects power structures rather than truth, that the official narrative frequently excludes those whose contributions were most essential. Katherine Johnson calculated humanity's path to the stars while society tried to confine her to a segregated basement, her brilliance too powerful to hide despite every institutional barrier placed in her way. The woman whose mathematics sent astronauts to the moon, whose calculations were trusted over computers, whose genius was hidden for half a century, finally received recognition, but countless others like her remain forgotten.